Fire. It's a mesmerizing dance of light and shadow. For millennia, it has been our constant companion, a tool that shaped human civilization. It warms our homes, cooks our food, and lights the darkest nights. But get too close, and that comforting warmth becomes a destructive force. It's a paradox we live with every day. But have you ever stopped to think about it? Beyond just, it's fire, of course it's hot. What makes it hot? What is this incredible phenomenon, really? It seems like such a simple question, right? But the simplest questions often hide the most fascinating answers. We see flames everywhere, a birthday candle, a backyard bonfire, even inside a car's engine. But we rarely stop to ponder the intricate science at play. Well, that's what we do here. Welcome to WhyOWhyTV, where we dive headfirst into the questions you've always wondered about. We're here to peel back the layers of the everyday world and reveal the surprising science hiding in plain sight. So, what fire? The first surprise: fire isn't a thing. You can't hold it. Fire is a process, a rapid chemical reaction called combustion. To get it started, you need three key ingredients known as the fire triangle: fuel, oxygen, and heat. Think of it like a recipe. You can have a pile of wood, that's your fuel, and all the air in the world, which contains oxygen. But without an initial spark of heat, nothing happens. Remove any one of those three elements, and the fire goes out. It's why smothering a fire works. You're removing the oxygen. This combustion is an exothermic reaction, meaning it releases heat. During the reaction, the fuel's molecules are violently torn apart and rearranged with oxygen to form new, stable molecules like carbon dioxide and water. This process of breaking old chemical bonds and forming new ones releases a huge amount of stored energy. That energy bursts forth as intense heat and brilliant light. The visible flame we see is a glowing, superheated cloud of these reacting gases and tiny particles like soot, all radiating that energy outwards. So the heat you feel from a fire isn't just hotness. It's the raw energy from chemical bonds, unleashed and radiating outwards. It's a transformation of matter into energy that you can see and feel. And that, in a nutshell, is why fire is hot. It's not a thing, but a process, a powerful, energetic release of stored potential. But this just opens up more questions, doesn't it? Like, why are some flames different colors? We'll get to that. For now, stay curious. This is WhyOWhyTV. Ever wondered why you can feel a campfire's warmth from feet away? It's not magic, it's physics. Fire is a powerful chemical reaction called combustion. To start one, you just need three things: fuel, oxygen, and a spark of heat. The famous fire triangle. When that heat hits the fuel, it breaks the chemical bonds holding its atoms together. Think of these bonds like tightly wound springs. The heat unlatches them, and they release their stored energy as heat and light. This released energy zaps nearby air molecules, causing them to vibrate and zip around frantically. This molecular dance party is what we perceive as temperature. The more they dance, the hotter it gets. And when that intense energy hits your skin, your own cells are forced into that same frantic dance. A little feels like pleasant warmth, but too much energy transfer damages them, causing a burn. It's a stark reminder of the power packed into those breaking bonds. Okay, so fire is hot. But hot? You don't need a fancy thermometer. For centuries, blacksmiths used a flame's color as a visual guide to know when metal was ready to be shaped. In a typical wood fire, the color comes from tiny particles of soot heated until they glow. The coolest parts glow a dull red, around 1000 degrees Celsius. As the temperature increases, the color shifts to bright orange and then brilliant yellow, reaching up to 1400 degrees. But blue flames are different. On a gas stove, a blue flame means the fire is getting plenty of oxygen and burning its fuel almost perfectly, a process called complete combustion. There's very little soot, so these efficient flames burn at over 1500 degrees. But wait, fire can be other colors too. Ever seen a green flame in a fireworks display? That's not about temperature, but chemistry. Burning certain elements emits specific colors. Copper burns green, strontium burns red. It's how we get those spectacular effects. Fun fact, the hottest flame ever recorded in a lab was over 3000 degrees Celsius, hot enough to melt steel in minutes. That's a lot of s'mores, if you like your marshmallows vaporized. So next time you see a flame, remember, its color is a secret code for how hot it really is. So you get too close to a flame, why does it hurt? It's all about a frantic energy transfer. You see, heat moves in 3 ways. There's conduction, which is direct touch. There's convection, where heat rides on currents of hot air. And then there's radiation, where heat travels as invisible infrared waves. Even without touching a fire, you can feel its warmth, right? That's radiation, zapping energy straight to your skin. But if you touch it, that's conduction. The heat rushes into your skin molecules, making them vibrate like they're at the universe's most chaotic dance party. When that intense energy hits, it's mayhem at the cellular level. The water inside your cells can literally boil. Proteins, the tiny machines that run your body, get warped and denatured. They cook, just like an egg, changing shape and ceasing to function. This cellular destruction is what we call a burn. A first-degree burn just damages the top layer. A second degree goes deeper, causing blisters. A third-degree burn can destroy all layers of skin and even the nerves inside. Fire isn't mean, it just dumps a catastrophic amount of energy into you, way faster than your body can handle it. Now here's a twist. Let's take our fire to a place with no up or down, space. On Earth, gravity is the secret artist that shapes a flame. Hot air is less dense than cool air, so it rises. This creates a constant upward flow, a process called buoyancy, which pulls the flame into its familiar teardrop shape. But in the microgravity of space, buoyancy is gone. Hot gas doesn't rise because there's no up to rise to. So fire gets weird. Instead of a flickering teardrop, it forms a calm, steady sphere. It pulls in oxygen and pushes out waste products equally in all directions. And it often glows with a faint, eerie blue light because the combustion is slower and more complete. It's still incredibly hot, but it looks less like a campfire and more like a tiny captured star. From a cosmic mystery to the cornerstone of our world. It's impossible to overstate how important fire was to our ancestors. This wasn't just a discovery, it fundamentally changed the course of evolution. Before fire, night was terrifying. A campfire created a circle of light and safety, fending off predators. It provided warmth, allowing our ancestors to survive ice ages and migrate across the globe. And the food? Cooking makes food safer and easier to digest. This unlocked a huge surplus of calories, energy that fueled the growth of our bigger, more complex brains. Yes, fire literally fed our minds. This control over energy was the first step on the ladder of technology. With fire, we could harden clay into pottery, and eventually melt rocks to forge metals. First bronze, then iron. This led to better tools, the steam engine, and the entire Industrial Revolution. Controlled fire literally shaped civilization. Imagine history without s'mores. I'm not saying humanity would have given up, but the lack of gooey, chocolatey goodness would have been a serious blow to morale. We might never have made it past the Stone Age. So, let's recap. Why is fire hot? It's combustion, a chemical reaction releasing stored energy. That energy hits us via conduction, convection, and radiation, and a burn is what happens when our cells get overwhelmed. We've seen how fire acts strangely in space, forming blue spheres, and how mastering it was essential for our survival and technological ascent. Fire is a paradox, a destructive force that enabled creation. This has been WhyOWhyTV. If you learned something new, give this video a like, share it with a friend, and subscribe so you never stop asking why. And here's your teaser. If fire is hot energy in motion, why is ice cold? Is cold even a real thing? That's a why for another time.